Hey, how's it going? Thank you for coming back for another video. Hopefully you're able to sit through the whole last video. And it was kind of long and I kind of skipped around a lot, but I was trying to get a lot of information out. And I haven't really done anything in a while, so I kind of was doing a little bit of, trying to just get caught up. But now we'll try to focus on one thing at a time. So here is the engine, and we're going to talk about that today. So it is a still the factory drivetrain. It's a 2006 Chevy Cobalt. It still has the factory OEM drivetrain. So that consists of, it is a Gen 1 L61 Ecotec. It is it has the factory cylinder head casting. It's not an LSJ or anything. It's still the L61. It is still an L61 Gen 1 bottom block, and it is still the factory transmission, which is an F23 get rag. But I want to kind of go through the motor and kind of what I did and why I did it. So it started its life as a regular 86 millimeter bone stock one, and I ended up putting the turbo on. It made 290. So I was kind of pushing the limits on the factory bottom end, so I did a factory drop-in Wesco piston Eagle rod combo, and I started making, more boost, more power, and then I started trying to build it for a little bit more power than that. So then I actually I was putting a Precision 6262 on it, so then I ended up bumping from the 6262. Well, when I did the 6262, I had the factory block and everything, but then I ended up calling up Bates Engineering because they actually had blocks there already. I didn't have to send anything over. They already had one in their, shop, so they were actually able to just throw fat sleeves in it for me. So I ended up just sticking with 86 millimeter because they already had the factory forged pistons and rods, or the Wesco pistons and Eagle rod combo, and I was going to just do it that way. And then I actually, after I did that, I put it all back together. I got it built by a local machine shop here called Budlong Motorsports with Farrah valves. I got the Amfab intake manifold. I did the larger valves from Farrah. I had some other springs and stuff in it, and then actually on the first startup, when the motor was built with the 6262, and I just got the block sleeved, on the first startup it actually dropped a valve. One of the Farrah valves broke, as a matter of fact, and it caused me to have to rebuild the bottom end again because I scored the cylinder wall pretty bad. So then I ended up getting them bored over a little bit, so I had to get different pistons made. So I was like, you know what, if I'm going to do it, I kind of want to do it to where I'm not going to worry about any of these components. And I knew I was kind of searching for the 700 horsepower range. So I was like, I went with stuff that I knew that would actually take the abuse, if not more than what I was aiming to throw at it. So I ended up talking to my buddy Trevor Jolly at Trevor Jolly Performance. Thank you, buddy. You're freaking amazing. Him and I kind of decided we were going to go with the custom Aries pistons. So I just went and we got some custom Aries pistons made for it. They're 10.75 to 1 compression. Then when I did that, I was like, I don't want to stick with an Eagle rod, so I called up Pewter and I got some Pewter X-Beam rods. And then I actually, before I did even all that stuff, one of the first things I sourced that was the main component with keeping the 2.2 liter was actually I didn't want to keep the 2.2 liter crank and actually just have that as one of the points, the weak links where it could break. So I actually found an Eagle forged crank. So we started running that one. So it's an Eagle forged crank, Pewter X-Beam rods, Aries custom heavy duty pistons. They have a 240 wall wrist pin on them. They're really, really heavy duty. They're made for whatever the rods can take, and these rods are typically good for like 250, 300 horsepower per rod. So I'm still not even there yet, so I should be good. I ran them to 46 pounds of boost, and we made 798 wheel horsepower. and that was with the AmFab custom intake manifold. That was with the bottom end that's currently in the car. Actually, it made 800 horsepower. I ran it a couple times, but then we were actually fixing another machining issue where I was leaking some coolant, so I actually had to get that fixed. So that's where the car came apart this last time. But then when I put it back together, we were so upside down as far as turbo back pressure that I just really was trying to do anything I could to try to get back pressure controlled. So if you actually give more length to the exhaust runners, you're actually able to get more air out of the cylinders, because there's more surface area, more volume in the exhaust that allows the air exhaust to flow into before it starts backing up with back pressure. So it actually allows you to get more air out of the cylinders, so it actually should make it happier. But I'm also running a 5-bar map sensor for my exhaust back pressure. So there's a canister down here now and map sensor, and that's actually just for turbo back pressure. It's actually just monitoring that so we can actually see how efficient the combination is now. But yeah, it has Ferrea oversized valves. We have custom AmFab intake manifold out of he's Mike, actually out of Arizona. Very nice guy. He actually hooked me up. We actually did his custom race porting to the cylinder head as well. So it's all port matched from the intake manifold to the head. And then yeah, everything's worked out really well. I've had a lot of inspiration from all of the front wheel drive Hondas, and I've used a lot of their components to be able to try to make it work. These are actually K-Series coil packs right here. These are from K-Series, and they're actually the Excel version, but they are one of the main reasons why I'm able to run 41 pounds of boost and not really have any issues. They supply a really strong spark, and they're smart coils, which just makes it really much better. They're much easier to work with. They have it's actually now, I used to be running wasted spark with the old Mega Squirt setup, the other computer that I had, but now actually even with the Mega Squirt I actually upgraded to this kind of a setup, and now we changed to full sequential injection. So we actually have full sequential injection now, and the car really runs really well. And it's also because of another Honda thing, was actually the T1 trigger that I'm running now. We were actually in development of trying to figure out a way to be able to run the motor and not have sync issues with the timing of the motor, and we constantly kept having issues with the external crank trigger, because when I ran the Eagle crank, it doesn't have a reluctor on it. So we had to, on the ATI balancer, we were actually putting I had a trigger wheel and a crank sensor, and we were constantly having issues with it actually losing sync, and actually it's like hitting a rev limit at like 5,000 RPMs or 6,000 RPMs. It just wouldn't rev any higher than that because it doesn't know the speed of the motor. It's like a safety feature, just cuts it, So we actually decided we were actually going to try to do something different. So I actually just looked at what all the Honda guys were doing, and the first idea we were actually going to run this guy. I just pulled him out. It's actually a brand new AEM engine position module, and we were going to actually run this off the cam, off of this side of the cam. I was going to move my regulator, and we were just going to take off this little cover, and then there's actually like a little hex driven by the cam, or like the hex end on the camshaft, and you could actually just get a little custom shaft made and like a billet adapter, and actually just run this so it actually can tell the time of the motor. But even these, I kind of started doing a little bit of research, and they have a small little rubber mounting. It's how they dampen the vibrations inside of this, and the way it picks up the signal, it dampens it, but it actually allows a small bit of deflection, and even that right there is not quite the best. There was actually a lot of other people running into issues even running these. If you're not rotating the motor too fast, like I've seen guys with big blocks running like 6,500 RPMs with these, no problem. As soon as you start pushing 8,500 plus and stuff, you know, it could be a potential issue. And I'm like, I didn't even want to deal with it. So I actually started looking around and seeing what all the Honda guys were doing, and a lot of them just run custom T1 triggers. So that's what we actually ended up doing. We just got a T1 trigger. It's a 4-wire sensor that is actually, it has cam, crank, you run power and ground to it, and it actually has, we have a custom cam gear over here. It's actually, well, it's one of the adjustable Bates engineer, oh no, it's just the adjustable cam gears. I forget which ones they are, but they were, they're just the regular cam gears, but we have had to, Trevor actually, and me actually had to figure out how to run them with the cam signal. So he ended up doing the like a special metal plate that sits over the cam gear, and it actually has 13 magnets on it, 12 at positive polarity and 1 at a negative polarity, and it actually picks up cam and crank signals both on that. And ever since we've done the T1 trigger, I have not had a single issue as far as timing with the motor. I'm able to rev it out no problem. I'm never losing sync with the motor, and it's been night and day as far as the other setup. And honestly, without that, we probably wouldn't be able to push it as hard as we've been able to. But a lot of little things here and there. That's why I try to dub it the Frankenbolt, because it's a lot of different components that I try to incorporate off of different, like, people that are making it work with the front wheel drive scene. So got to do what the fast guys are doing. So that's kind of what I inspired to do. I try to do things right. I wanted to do the turbo up in the front like this, just to be able to get more weight up in the front and ease of working on the turbo now, because the turbo is just so much easier to work on when it's up here, opposed to hiding down behind the motor where it's not getting anything but hot air, you know. So I just kind of wanted to try to change it up and do something myself. But yeah, it's been an awesome experience working on this thing and trying to get it to where I want it. But yeah, it has we ended up using the components we did just because that's, you know, what was available to us at the time, and it was the stuff that I felt I could rely on. And honestly, it's worked out pretty good in the end. You know, it's nothing too crazy. You know, you have like higher compression pistons, you have off the shelf rods. The crank is kind of hard to get, you know. You just a regular sleeving, you know, nothing crazy, no grit, no reinforced griddles or anything, you know, just like a little bit of a factor ductile sleeve, and then some nice porting, large size turbo. I'm running 2000cc injectors in it, and you know, we've been very, very good so far. Trevor actually got me he has his custom fuel system in the car. We have it's a regular, I have a Walbro 450 in tank in the factory tank under the rear of the car that is actually feeding the surge tank, and the surge tank has two pumps in it that actually feed the rail. So we got surge tank under here. It's got two AEM 320 liter per hour pumps, and both of them are feeding the rail. So I was actually able to run one of them to, I made like 660, 670 almost wheel horsepower before the single pump started limiting out. So then we actually, I just kind of wanted to see what one pump could do, but two of them will easily supply what it made, if not more. So, but now with the new setup, it should be a little happier. The main reason I did it was just to try to help out all the cylinder back pressure, because as much volume as you have in the exhaust, it just allows everything to just flow happier and healthier. You know, you're just able to actually, well, get it to where it is actually happy, because the car would make good power at lower boost pressures, but you start pushing it 40 plus pounds, it was really limiting as far as the exhaust flow out of the motor. So we'll kind of see what the new setup does. I should be hopefully getting it fired sometime this year before the year ends. So as it sits, didn't really try to tuck anything out of the engine bay too much. I actually have there's a scatter shield for the twin disc clutch in case it ever explodes. I try to do things the way that if I ever ran it at a track, I'm not going to get kicked out for not having something done the right way, you know. And the only last thing I'm going to need is probably a belly pan under it. But this is as it sits now. The racing brakes on them and everything. Ready to fire up. I've already been kind of calibrating the sensors, already calibrated the TPS and the throttle body. I already, which is the throttle body. I already I'm already getting most of everything calibrated, so it should be pretty much ready to just tune when I get it over to my buddy Eric at SQC, who I'm repping today. SQC. He's the reason why this car is at the level that it is, because without Eric's help, I honestly would not have been able to do this, because I was, you know, being somebody that it doesn't really, you know, this is just a hobby that's kind of built to where it is today. You know, I never expected I was going to have a full drag Cobalt that is at almost 800 horsepower, and being one of the only guys in the United States that even has something like that, you know. There's other companies that have done it, but not like a privately owned car that's just done by some dude in his garage. So it's I'm pretty happy with it, you know. It's definitely surpassed my goals and then some, and you know, I honestly, without the people in my life that have, you know, helped me, you know, I wouldn't be here, you know. Without Trevor helping me with the bottom end, he actually built this motor. The last one was done by Budlong Motorsports, and then when the valve dropped into the motor, I kind of wanted just somebody that was actually like an Ecotech guy to kind of go through it. Nothing against Budlong Motorsports, my local machine shop, they kill it. They do some, you know, fast cars. You know, they really know what they're doing. And honestly, if I ever got it done locally, I'd probably trust them to redo it. But I just wanted him to kind of go through it, because you know, he always had my back, and he always, you know, seems like he, you know, knows what he's talking about, and he's ahead of the game as far as certain things, and you know, he's very open-minded, and he likes to kind of think outside the box. So that's what I like about Trevor. You know, we kind of go back and forth with ideas, and we kind of make stuff work. And this car right here is an example of that. You know, without Trevor, it wouldn't be here, and then without Eric, I wouldn't have been able to tune it like this. And even without some of the companies that kind of let me down in the end, you know, like if, you know, certain things weren't the way they were, if I wasn't able to not find a tubular turbo manifold, I probably would have just bought one off the shelf. If I had like a freaking Honda Civic, I probably would have just had a basic, you know, turbo manifold that you could just buy from any company. But because I have a Chevy Cobalt, I kind of had to kind of try to do it myself, because nobody's really doing it. So that's the main reason why I'm here. But I'm actually very happy with it, because it's definitely surpassed my goals, and I have even higher expectations of it now. So we'll kind of end up seeing where it ends up, you know. But thank you so much for trying to tune in. Hopefully these aren't too dry and annoying videos, but you'll see what happens in the future. I gotta go power up some circuits and actually figure out what's going on with the sensors. I just need to set the voltage offset for a couple of the sensors, because each sensor has its own, depending on the voltage and pressures that it's seeing, the voltage, you can actually adjust it by setting the voltage offset, and I haven't done that yet. So now the oil pressure and a couple other pressures, like the sensors, are kind of a little off, so I just need to set those, and then everything should be pretty much ready to bring to the tuner. I just haven't had much time outside of working on customer stuff, but I'm hopefully here soon. we'll get it going. But tune into that video. Hopefully I'll get that fired up here in the next couple weeks, I hope. We'll see. I don't know.